First of all, please check your gradings every week for comments. Okay, for many of your submissions, I do have comments. I did point out where things go wrong, where you can do better. So please check your gradings. Sometimes I made mistakes while grading. So if you check your grading, you can also let me know what I did was wrong, so that I can improve your grade. Also, second point, please reply to my email, or I will send you a second one, a third one, a fourth one. So by saying my email, I mean the email particularly sent to you, not to the general class. So you can clearly read. Sometimes I want to talk with some of you about our class, about your submissions, about my gradings, and about your homework. That's why I send you the emails. I want you and me, we can collaborate so that your performance can be improved. Okay, so definitely check your email. If you have not replied to my email, I send you another one. Get ready. I send one after the other one. Okay, I keep sending you emails. Third, we have a quiz almost every week, except for exam weeks. Except for exam weeks, we have a quiz almost every week. So make sure you automatically review what you have learned last week. Okay? Any question before we go to today's class? Okay, so I hope that is obvious. If you have any question, feel free to drop me an email or talk to me after class. So today's class, we are doing section 8.5, which is called the sum and differences formulas. First of all, let's watch a video how we prove the formulas we have on the lecture notes. On the lecture notes, the formulas are provided, but the proofs are not provided. Let's watch this video. This video is just 17 minutes long. Okay. So let me know if you cannot hear me or hear this video.
We're going to begin by drawing a picture of our unit circle. All right, so on our unit circle here, we're going to call the origin here O, the point O, and then this point out here, we're going to call P, and it's got ordered pair 1, 0 because it's the unit circle. The distance from the origin to the spot on the unit circle is 1. Then we're going to draw an angle. We're going to call this angle B. So angle B gives us an ordered pair out here on the unit circle that we're going to call point Q. And it has ordered pair cosine B, sine B. Right, just from the definition of the trig functions from a few videos back. Right, so now we're going to put on a second angle, angle A, right, always over here, angle A. And that's going to give us a point on the unit circle that we're going to call point S. And it has ordered pair cosine A, sine A. Again, from the definition of the trig functions from a few videos back. Right, so now what we're going to do is we're going to put in a third angle in here, where we go angle A, and then we're going to take B away. If this is angle B, right, we're going to come all the way over to angle A and then come back angle B right inside here, and that gives us this new angle, right, that's in blue, called A minus B. No, it's not perfectly to scale, but you get the idea. All this is angle A, then subtract off whatever B was, and that leaves you this new angle here in the blue line, and we're going to call that angle A minus B. That will give you a point on the unit circle that we're going to call R. And it has an ordered pair cosine A minus B, sine of A minus B. This blue right here angle is angle A minus B. And in addition, though, what if we said, well, all of this is angle A, all the way over the orange. But instead of taking B off this way, giving us the blue line, let's take B off over here from the x-axis. We take this off. Then that's going to leave us the angle SOB. Q. Everybody see that right there? That angle right there. What's that angle? If you start with A, all the way over to orange is A, from the green line all the way over to A, and then you take off this B right here, and that leaves you this new angle, which brilliantly enough is going to be called what? It's also A minus B. So the blue angle is A minus B, and the angle between the red line and the orange line is also A minus B. They're the same angle. Okay, it's important to realize. All right, so how does that play into it? Well, since we're on the unit circles here, these points that we have can make what are called chords. Okay, and so there's a chord that goes from point R to point P. So that chord right there is what's opposite angle A, this blue A minus B. And it's called chord RP. But then there's also this other chord that's between S and Q. And S and Q has a certain distance, and R and P have a certain distance. And what do you know about those two distances? If we know that this angle here is A minus B, and this angle between the red and the orange is also A minus B. Well, then these distances, these two chords, RP and SQ, have to be the same length because we're all sitting out here on the unit circle. All these distances here is 1. Okay? The red, the blue, and the orange, all those distances are 1. All right, so then we know that RP, chord RP, notation for chord RP, has to equal the chord SQ, just because the angle opposite those chords are the same. They're A minus B, right? So what's the length of chord RP? Well, you've got a point R and a point P. It's pretty easy to figure out the distance between 2 points, right, using the distance formula. And the same idea between S and Q. Use the distance formula for S and Q. When you do that, you look something like the following. Okay, we've got cosine A minus B minus 1. That would be the x value minus the other x value squared. This is strictly from the distance formula. If you do not remember the distance formula, then you need to go refresh your memory on that. Then plus the sine of A minus B, this y value for R, minus the y value for P, would be sine of A minus B minus 0 squared. All of this represents this distance between R and P, right? Well, that's going to equal the distance between S and Q. Well, the distance between S and Q is the square root of cosine A minus cosine B. The x value of S minus the x value of Q would be this thing right here, squared, plus the y value of S sine A minus the y value of Q sine B squared. So the distance RP looks like this. The distance SQ looks like this. Everybody follow me? Looks ugly because you got all those cosines and A's and B's and stuff running around, but it's really just the square root of x2 minus x1 squared plus y2 minus y1 squared, the distance formula from way back when. Okay. All right, now we're going to do nothing but a bunch of algebra. All right, so we can square both sides, get rid of the square root. And then what do we have inside here? We have the cosine of A minus B minus 1, and all of that is squared. Well, that's really just a binomial squared, right? That really means cosine A minus B minus 1 times the cosine of A minus B minus 1. And then we're just going to multiply that out. Okay? So don't let that freak you out. That's all we're going to do. Right, so when we get our next line, it looks like the following. Cosine A minus B minus 1, quantity squared, goes to cosine squared of A minus B minus 2 times cosine of A minus B plus 1. So these first 3 terms right here come strictly from the cosine of A minus B minus 1 squared. And that's just multiplying that binomial squared out. And what do we have over here? Well, we have the sine of A minus B minus 0. Well, that's just the sine of A minus B. And then we're going to square that. And so that's where this plus sine squared of A minus B is coming from. So this part right here is just coming from this part. Right, then equals. And now we have the cosine of A minus the cosine of B. Well, again, this is a binomial squared. So write this as cosine A minus cosine B times cosine A minus cosine B, right? And then just multiply it out. When you do that, you get cosine squared A minus 2 cosine A cosine B plus cosine squared B. Right? And do the same thing with this last binomial squared, sine A minus sine B squared. Rewrite that as sine A minus sine B times sine A minus sine B, and then multiply those two binomials together, and you'll get your sine squared minus 2 sine A sine B plus sine squared B. So all of this blue goes to all this mess in red, right? It looks scary, but it's really nothing but a bunch of algebra. And if you just go off some scratch paper and write it down and multiply it all out, you'll see where all this stuff in red is coming from. Okay, so now we can do a little combining of terms. For example, cosine squared A minus B and sine squared A minus B. These two things right here, what do they go to? Well, if you add them up, you get 1. Because cosine squared theta plus sine squared theta is equal to 1 from one of our identities that we had in a previous video. So that goes to 1. You've got another 1 over here. So the 1 plus 1 is 2. And then you've got minus 2 cosine A minus B. Everybody see that? Okay, it's the same idea that's going to happen on the right side. Right? So this left side goes to 2 minus 2 cosine A minus B. And then the right side, well, you've got cosine squared A and plus sine squared A. Well, that goes to 1, these two. And then you've also got cosine squared B plus sine squared B. Those also go to 1. So 1 plus 1 gives you 2. So this 2 is coming from. And then you've got minus 2 cosine A cosine B, and then minus 2 sine A sine B left over. Right, so we can subtract 2 from both sides, and then we can divide both sides by negative 2 to give us the following. Cosine A minus B equals cosine A cosine B plus the sine A sine B. This is our identity for the cosine of A minus B. So now we know this is true, we can use it. So for example, we know that cosine A plus B is equal to cosine of A minus negative B, because A plus B is the same thing as A minus negative B. Then we can use this identity that we have up here, right? So that goes to cosine A times the cosine of negative B, right? Because your second angle here now is negative B, plus the sine of the first angle, A, times the sine of the second angle, which is negative B. And that's going to leave you, well, cosine A, and then cosine of negative B. Well, recall that cosine is an even function, and the cosine of negative B is the same thing as the cosine of B, right? And then sine of negative B. Well, sine is an odd function, so the sine of negative B is actually the same thing as negative sine of B. And so you got this negative 1 that's sitting out here, which changes this to a minus. So minus sine A sine B. And this would be our second identity, but this would be the one for the cosine of A plus B. I don't let all the A's and B's kind of freak you out. Really, all this is saying is the cosine of two angles added together is the cosine of the first angle times the cosine of the second angle minus sine of the first angle times sine of the second angle. That's really all that's saying. You're really not going to have A's and B's running around. You're going to have other angles, right? Okay. All right, let's move on to sum of difference for sine. All right, recall that sine of theta is the same thing as cosine shifted, right? So like cosine pi over 2 minus theta, right? Those two things are equal, right? So we're going to use that here. So we got the sine of A plus B being our angle.
By the way, I should pause the video a little bit. So do you guys have any question about the proof of cosine?
Just to follow on a little bit later, would we be able to get the link for this video?
Yes, I posted in Canvas.
Oh, okay.
Thank you for reminding me.
Thank you, Professor.
If I forgot to do anything, feel free to drop me an email. I should have this post to Canvas at the end of the class, okay? So that you can watch it again. Anyone has any question how we get to those two? Okay, so I understand, since I'm also a student, I feel the algebra is kind of messy here. So it's very hard to get through all the algebra calculation when we first look at it. So let's just watch this video until the end of this video, which is another nearly 5 minutes. Then we will do some actual questions on using those sum and difference formulas, okay? So don't worry if you do not get it right now. You can always watch it later. I'll post a video link, okay? Let's continue.
Right, those two things are equal, right? So we're going to use that here. So we got the sine of a plus b being our angle. Well, that should be the same thing as cosine of pi over 2 minus that angle, a plus b, which we'll put a little, there we go, cosine pi over 2 minus our angle, a plus b. All right, well, now we can do a little algebra. Cosine of pi over 2 minus a plus b, distribute the -1 through, you get pi over 2 minus a minus b, and then we're going to group them as pi over 2 minus a. We're going to group all that together, so we have parentheses, and then minus the b. So now we've rewritten sine of a plus b as the cosine of pi over 2 minus a, all that angle, minus the second angle b. Everybody see that? First angle, second angle. And then we can use our previous identity and go, that's the cosine of the first angle, pi over 2 minus a, times the cosine of the second angle, plus sine of the first angle, times sine of the second angle, b. Everybody cool with me on that? That's just coming, the green thing here is just coming straight from the identity that we had on the previous screen. So now we can say, all right, well, what's the cosine of pi over 2 minus a? Well, that's just a shift, right? Going back up here to our recall of our identity here in black. Cosine of pi over 2 minus a should be the same thing as just the sine of a. So cosine pi over 2 minus a goes to sine a times cosine b, plus, same idea here, sine of pi over 2 minus a goes to cosine a, and then times the sine of b, right? So we're using some previous knowledge to go from the green line to the blue line. But this is our third identity. This is the sum of two angles for sine. The sine of two angles added together is the same thing as the sine of the first angle times the cosine of the second angle, plus cosine of the first angle times sine of the second angle, right? And now that we have this identity, we can do the difference one. Sine of a minus b is the same thing as the sine of a plus negative b. And now we can use this identity right above it. See, all right, that means the sine of the first angle times cosine of the second angle being negative b, plus cosine of the first angle a times sine of the second angle negative b. And we use the fact that cosine is an even function. So cosine of negative b is the same thing as cosine b. So sine a cosine b. And then sine of negative b is an odd function. So that's going to go to negative the sine of b. And we're just going to change this positive here into a negative, because it'd be a -1, right? That goes to minus cosine a sine b. So the sine of the difference of two angles is the sine of the first angle times the cosine of the second angle minus cosine of the first angle times sine of the second angle, right? So let's summarize. All right, so the sum of difference identities. The cosine of the sum of two angles, right, goes to the cosine of the first angle times cosine of the second angle minus sine of the first angle times the sine of the second angle, right? And then sine of the sum of two angles, you get the sine cosine plus cosine sine. All right, so everybody kind of notice here, we've got a couple things to keep in mind. Cosine of the sum, or the cosine of the difference, but they both go cosine, cosine, sine, sine. Follow me? Cosine, cosine, sine, sine. Whereas sine, right, the two sine identities go sine, cosine, cosine, sine. They alternate. So that's one way that can help you keep them straight as opposed to what identity goes with what. So you can remember the identities. Another thing we notice is that sine of a plus b and the sine of a minus b, there are two signs, whether it's an addition or a subtraction, they carry over into the identity, right? You got a plus here for the sum, and we've got a minus here for the difference of two angles. But for the cosine ones, they're the opposite. So if it's the cosine of a plus b, then you're going to be doing a subtraction between the two parts. And if it's the cosine of a minus b, then we're going to be doing an addition between the two parts. Right? So you got to find some way to keep those in mind so we don't mess up the sign, which is obviously easy to do. All right, so those are the four identities. From there, we could get two more, the tangent ones. From these four up here, you can derive 5 and 6. I'm going to leave that as an exercise for you guys to figure out. All right, so that's it for the derivation of the sum of difference identities. Make sure you see the video where you have several examples on using them. All right, that's it. Study well.
Okay, so we finished watching this video already. Does anyone has any question about it? Okay, so in this video, at the ending, he says we will leave those two formulas as exercises. I'm going to do it right now on paper. So, okay, why they are true? Using the facts we already get from cosine and sine. Okay, I'll do it on paper. Switch to paper. Okay. In the video, we get those formulas, right? This is left as the exercise. Let's do it right now. Y tangent alpha plus beta is this one. So again, every time you see something complex as tangent, you convert it into cosine and sine, which is something more basic. And start your calculation from there. Okay. Every time you see something complex as tangent, you convert into sine and cosine. So what is tangent? By definition, what is tangent alpha plus beta? It's sine alpha plus beta, cosine alpha plus beta. Right? Just the definition. No technology here. But look what we have. We already get what is sine alpha plus beta, what is cosine alpha plus beta. We just substitute those into the formulas to see what we get. Sine alpha beta equal to sine alpha cosine beta plus cosine alpha sine beta. What is cosine alpha plus beta? Cosine alpha plus this is our sine and cosine, right? So how can we do this? How can we convert this into something like this? Again, on the right side, you see a bunch of tangent. Here you only have sine and cosine. So why don't we convert those sine and cosine into tangent? How do we do that? There's an easy way to do that. We divide everything by cosine alpha and cosine beta. We divide everything by this guy. First of all, if this guy divided by this guy, you get a 1 here. I hope that's a 1 here. That's what you get. If sine alpha sine beta divided by cosine alpha cosine beta, what do you get? Let me write more clearly. Okay, times, I don't have enough space to write here, that's why I moved here. Times, since we're dividing everything like this, we times 1 over cosine alpha cosine beta, 1 over cosine alpha cosine beta. This is just a 1, okay? This is just the same thing over itself. Since we want to divide everything here with cosine alpha cosine beta. So if you do such a division, what you get? This times this times this part is sine alpha cosine beta cosine alpha cosine beta plus cosine alpha sine beta, cosine alpha cosine beta, cosine alpha cosine beta, sine alpha sine beta, cosine alpha cosine beta. Here's what you get. Any question on this step? I just multiply the fractions into everything and separate them. Okay. Still looks very messy, but we are approaching the end of this proof already. You see, obviously, this guy divided by itself, you just get a 1. So here is 1. What is here? Sine alpha over cosine alpha. You get tangent alpha. Sine beta over cosine beta. You get tangent beta. Sine alpha over cosine alpha. What do you get? Tangent alpha, cosine beta over cosine beta cancel out. So you just 1. This guy times 1 itself. Cosine alpha cancel out. Sine beta over cosine beta, tangent beta. Now you get the formula you want to prove. Okay, any question on how we get this? I know, algebra is messy. Don't worry, if you're stuck anywhere, feel free to go back and watch this video or ask me. So once we get here, how do we prove the negative component of it? Like this. Again, we use exactly the same technique as we did for sine alpha minus beta or cosine alpha minus beta. We just switch a sign of beta. So what if we have tangent alpha? So tangent alpha minus beta is just tangent alpha plus cosine minus beta. Okay, then you can use this formula. Tangent alpha still there, plus sine still there, tangent negative beta. Then you have 1 minus, tangent alpha is still there, beta is negative beta. So you have tangent alpha minus tangent beta. Because tangent function is an odd function, you can factor this negative sign to the front. 1 minus tangent alpha. This is odd function, so you can move this negative sign to the front. However, you already have a negative sign. So I apologize. We should add a vertical line. 2 negative signs give you a positive sign. That's it. Okay, odd function, negative cancel you. That will get a positive. That's it. That's the 2 things we want to prove. Any questions so far? Okay. So we are done with the proof part. Now we should be able to just do everything, every question on these lecture notes. First question, cosine 165. This looks a very big value. What can we do with such a big value? We break into smaller values, which we are more familiar with. So what is 165 is 90 plus 75, right? So what is cosine 165? It's cosine 90 plus 75. Okay, you see two angles plus with each other. We still don't know what is 75 is, but don't worry, we can still further break this down. So what do you get? Two angles that apply this formula. Okay. Cosine the first guy minus sine first guy this guy. So what is this? Cosine 90 degree. Can anyone tell me what is cosine 90 degree? Yeah, it's 0. I apologize, I read it too fast. Can anyone tell me this one? What is sine 90?
It's 1.
Very good, thank you. 1. 0 times anything is 0, so you can just cross this out. Then you have negative 1 times sine 75. 1 is just there. So it's negative 1 times sine 75. You got sine negative 75. Okay, any question on how we get this? Well, we still don't know what is sine 75. Okay, we can further break 75 degree into smaller values, which we know already. It's 30 plus 45. That's 75. 30 plus 45. So sine 75, what do you get? Let's figure out what is sine 75. Sine 75 is equal to sine 30 plus 45. Okay, so again, you can apply this sine this angle plus this angle, sine cosine plus cosine sine. That's it. Sine 30 degree cosine 45 degree plus cosine 30 degree times sine 45 degree. That's it. Every value, we know it already. Sine 30 is 1/2. Cosine 45 is square root 2 plus 2. Cosine 30 degrees square root 3 over 2. Sine 45 square root 2 over 2. So what do you eventually get? This is square root 2 over 4. This is square root 6 over 4. Okay? But any question on how we get this? We just do some algebra, merge them. But we want negative sine 75 here. So the final answer is just negative without a value. That's it. Anyone has any question? Okay. No question? Something so easy to you guys? Okay. So how about this? I give you 5 minutes to think about this, okay? 5 minutes to think about this for the second question. It should not be too hard. Do it for 5 minutes. Use all the knowledge you know here. You should be able to solve it. I'll give you 5 minutes. Okay? 5 minutes to solve the second question. So, does anyone figure out this plan?
I got as far as knowing that it is equivalent to sine 20 minus 80.
Very good, very good. Look what you have here. This fall into the category of this formula, right? Just fall into the category of this formula. So this is your alpha, this is your beta. So this is sine alpha times cosine beta minus this guy. So eventually you have sine alpha is sine 20, cosine beta is cosine 80. So it's sine alpha minus beta, which is sine negative 60 degree, which is negative sine 60 degree, which is negative square root of 3 over 2, because this guy is square root of 3 over 2. That's it. Anyone has any question? So, seems that we are having an easy class. Our next page and our last page. Sine alpha plus beta. Sine alpha plus beta. What do we know? We know such a great formula we just learned. Right? This is a great formula learned. In order to figure out every component of this formula, you first have to figure out the sine alpha. Sine alpha is given here. That's great. How about cosine beta? Cosine beta, well, it's not given. We have to use this information to figure it out. So again, what is cosine beta? We don't know. Instead, we turn to the unit circle for help. We are told that tangent beta is negative square root of 3 over 2, and it is on the second quadrant, beta. So if this, so tangent beta is this divided by this, is negative square root of 3 over 2. So let's set this side to be square root of 3, this side to be 1. I apologize. Now we're not using a unit circle. Instead, we just create an arbitrary circle to enclose this triangle. Okay, this side is next square root of 3. This side is 1. Well, this is not a unit circle. Okay, so what is the length for the hypotenuse? Can anyone tell me what's the length of the hypotenuse?
2.
Very good. The c squared, which is hypotenuse, is just square root of 3 squared plus 1 squared, which is 4. So c is 2. So what is cosine beta? Cosine beta is 1 divided by 2. However, since we're in the second quadrant, cosine is negative because the x-coordinate is negative. So it is negative 1 divided by 2. That's it. Okay, we figured out this part already. So what is sine beta? Again, we can figure out from here. It's square root of 3 divided by 2. We are in the second quadrant. All students take calculus. So sine is positive. So sine beta square root of 3 over 2. That's it. Any question?
Can you elaborate on how you knew where to draw the triangle on the unit circle?
Very good question. Let me grab another paper. Let's just use this paper. So first of all, I apologize. I said I draw a unit circle at the beginning, but actually we are just drawing an arbitrary triangle, an arbitrary circle to include this triangle, okay? First of all, let's see. We are told it's in the second quadrant. So we should draw some triangle in the second quadrant. Second, the tangent of this guy is negative square root of 3. So what does tangent mean? It means for any reference angle, the opposite side divided by the adjacent side is square root of 3. We do not consider the negative sign here, okay? Because we're just using the reference angle. We just draw a fabricated triangle to include this. So if we fix this side to be 3, this side is automatically 1, so that their ratio is square root of 3 over 1. Okay. Does anyone has any question about this step? We just create the scenes proportionally. Create. So once we create this side square root of 3, this side is 1. This side by the Pythagorean theorem, c squared equal to square root of 3 squared plus 1 squared. You got 3 plus 1, which is 4. So 3 is 2. That's it.
Thank you, Professor.
Great, thank you. Then we can use this created triangle to figure out all the other trigonometric values. But make sure you follow the A, S, T, C rule so that your trigonometrical values will be using the correct sign, okay? ASTC rule, all students take calculus. All the trigonometrical values are positive. Only sine and 1 over sine, which is cosecant, is positive. Tangent is positive, others are negative. Cosine and second function are positive, all others are negative. ASTC. Okay, any question before we continue? Let me repeat the key idea. Just create any triangle that works. It does not have to be on the unit circle. I apologize for saying unit circle at first, but just create any triangle you would like so that the ratios would work. Just the ratios would work, that's enough. Okay, let's continue. So get our sine beta is square root of 3 over 2. The next thing we should get is cosine alpha. We know what is sine alpha. So cosine alpha, how do you get it? Cosine alpha, sine alpha squared plus cosine alpha squared is 1. So cosine alpha is 1 minus sine alpha squared. But, oh, I apologize. This, oh yeah, I'm still right. This is still in the second quadrant. because you are using the, oh, apologize, this is in the third quadrant already. Third quadrant, this is the second quadrant. So if you, let's rewrite, if you do the calculation, cosine alpha equal to 1 minus square root sine alpha. How about the sine in this third quadrant? ASTC. So this, this, both the sine and the cosine.
I have a question.
Yes, please.
So like the question is already give us like, given sines A equal 5/13 and then B. Oh, okay, got it. Sorry, you got it.
Okay, you got it. Well, I think that I'm still right. I made a mistake. This is not a third quadrant. This is still the second quadrant.
Yeah, I was about to say because the negative pi, it
Yeah.
makes like the backwards.
Yeah, this
Okay.
makes me feel confusing. Well, I was right at the beginning, then I changed my mind to the wrong idea. So this is negative pi. This is negative 2 pi, 3 pi over 2. So this should be here. So still the second quadrant. Apologize for the confusing. So let's just continue as what we supposed to do originally. So on this side, cosine values are negative because you are on the negative side of the x-axis. So make sure you put a negative sign here. So negative that guy, 1 minus sine squared alpha. If you do the algebra, eventually you will get negative square root 2 over 13 here. There's just some algebra here. For time issue, I omit here. If you have any question, feel free to ask me by email or after class. Yeah, this is just routine algebra. There's no trigonometry here. Great. Well, after we get messed up so many times, so what do we get here? Let's use a borderline to divide those guys so that things will not be messed up. Apologize, looks ugly here. But this part is for the beta, this part is for alpha, this is also for alpha. Then this part is for the alpha plus beta. Then once you get every value, it's just 13 times negative 1/2 plus square root 3 over 2 times negative 12 over 13. Then just purely algebra. And once you add everything together, you should be able to get 12 square root 3 minus 5. That's it. That's the final answer. Looks messed up. But this part is for beta. This part is for alpha. This is for alpha. Then you just plug every value into it to get what is alpha plus beta. Any question?
What does the final answer say again?
This one in the
What
circle.
does it say?
Okay, thank you for asking.
Is that a 26 in the denominator?
Yes, 26, 2, 6, 12, 3, 5. So when I was preparing for the class yesterday, I actually write things more neatly. This is what I prepared on the draft. So this looks more clear to you, right? So now you see the difference. When you are speaking to a public, you are more likely to get things messed up when you are just speaking with yourself, right? Apologize. Okay, any question before we continue to this one? Well, for this one, you are just figuring out what is tangent alpha, what is tangent beta. This is what you are trying to figure out. What is tangent alpha, tangent beta? So we don't know what is tangent alpha. However, we know what is sine and cosine alpha already. So tangent alpha, it's just sine over cosine. And now you see the cosine is this one, sine is this one. The sine over cosine is negative 5 over 12, just this divided by this guy. So what is tangent beta? Tangent beta is given here already. So it's just negative square root of 3. Then you just plug every value into this. Plug every value into this. Negative 5 over 12 plus square root of 3. 1 plus 12 times square root of 3. Because all of them are negative, so negative times negative give you positive here. So then just purely algebra here. Eventually you should get something like this. Negative 5 plus 12 square root of 3. 12 plus 5 times square root of 3. After some cancellation, you should be able to get 69. This is what you should be able to get eventually. This is 12. 12. Okay, 12. Okay, clear? Now it's clear. Everything's clear. Anyone has any question?
Instead of writing 12 square root of 3 minus 5 twice, can we just do 12 square root of 3 minus 5 squared?
They are different. Just pay attention. This is 12 times square root of 3. Here is just.
I see now.
Okay.
I see. Yeah.
I know things look tricky. Once they get messed up, they look very so tricky, so confusing.
Okay, makes sense.
Okay. Anyone has any question before we do the last question today? Okay, last question. Tangent this guy. Well, we don't know what this guy is. And this looks to be a very small angle. Previously, we learned the angle pi over 3, pi over 4. But this is pi over 12. This is to be small. How do we get a small angle? we do some subtraction. The trick is 12, pi over 12 is pi over 3 minus pi over 4. That's a whole algebraic trick here. Do you guys get it? Once you are done with this, then just apply the formula. Apologize. This minus this, you're going to get tangent pi over 3 minus tangent pi over 4, 1 plus tangent pi over 3 tangent pi over 4. So what is this guy? Tangent pi over 3. Can anyone tell me? I know it's very hard to memorize a few basic values. So let's use more basic values, sine and cosine, to derive it. Sine over cosine. So this is square root of 3 over 2 over 1 over 2, which is square root of 3. Tangent pi over 4 is square root of 2 over 2, square root of 2 over 2. So this is just a 1. Okay. Now you got all the values you need. So this is square root of 3 minus 1, 1 plus square root of 3. The last step is do some simplification. Then you can times this guy with 1, this conjugate. What is this conjugate? Conjugate is 1 minus square root of 3, 1 minus square root of 3. That's its conjugate. So if you do such a calculation, 1 minus square root of 3 is 1 minus 3 for the bottom. For the upper part, square root of 3 minus 1, 1 minus square root of 3. This is negative 2. This is different sign with this. So it's negative square root of 3 minus 1. Just pull out the negative sign here. So that would be the same. Thus you get negative square root of 3 minus 1 squared. Okay, this is just a negative of that. I factor the negative sign out so that the negative sign can cancel with this negative sign. So eventually you have two over 4 minus square root of 3. If you complete the squared, you get this. You finish the division, you should be able to get 2 minus square root of 3 root. That's it. Any question? This is just algebra. Okay. Once you find all the trigonometrical values, then the leftover job is just plug into the values, do the algebra. Okay. Anyone has any question on this one or any of thing we covered in today's class?
Can you do number 2 again?
Great. So is this the question you were asking?
Yes.
Okay. You first look at this one. You recognize this fall into the category of that formula. sine alpha minus beta, this formula, right? This falls into this category. Then you figure out which one should be your alpha. This one should be your alpha. This one should be your beta. Once you make sure this is your alpha, this is your beta, then you just use that formula to go backward. This time will be sine alpha minus beta. Sine alpha minus beta is just negative 60. Then you have negative sine 60 equal to negative square root of 3 over 2. Okay. Did I answer your question?
Yes.
Thank you for asking. Okay, anyone has any question about today's lecture notes? Let me repeat a key idea. Figure out all the alpha, beta, then just use the formula. You can go this way. You can also go this way if you are given with this way. That's it. There's no technology besides the algebra calculation here. Okay, algebra can be messy. Do it slowly and double check it again and again. Okay, we still have the one last thing to do before we leave today's class. This is our quiz 5. I'll give you 1 minute. Please open your quiz 5. See my gradings and your grades. Okay, open your quiz 5 in the canvas. Open your quiz 5 in the canvas. So I think everybody has opened the quiz 5 already in the canvas already, right? So let's look at quiz 5. First, finding the inverse of this guy. Do you guys remember how we did that? We first translate into some angle we know. In this case, we don't know negative 1/2, but don't worry, we know 1/2, right? Sine pi over 6 is 1/2. So what do we get for the negative value? So sine negative pi over 6 is negative 1/2. Then you can go reverse. Inverse sine negative 1/2 is just negative pi over 6. That's it. Anyone has any question? Okay. Okay, B, we don't know what is cosine theta equal to 2, but we translate into something we know. So cosecant theta, we don't know what it is. It's just 1 over sine, right? Equal to 2. So sine is just 1/2. So what is theta? Sine theta is 1/2. Theta is just pi over 6, right? How about this guy? Now you see a cosine negative value. You don't know what this angle is. Always, this is just your angle. But you can rewrite cosine this angle equal to negative 1/2. There are two possible terminal points on the unit circle, either this one and this one. But cosine, the inverse cosine, the range is only on the negative to pi, or 0 to pi. So it's only on this side. So only this terminal point is possible. So theta is 3 pi over 4. That's it. Okay, any question how we get this one? Similar with part D. We don't know what this angle is. Okay, this is the angle. So tangent, this angle is negative square root of 3. Okay, there are two possible terminal points on the unit circle. But inverse tangent range is only on negative pi over 2 to pi over 2, which is on this side. Only the second one is possible. So second one, this is a frequently encountered value. So the theta corresponding to it is negative pi over 3. Okay. So in order to solve those questions, you have to memorize a few basic values like pi over 4, pi over 3, and that's it. Once you get those popular values, then all other complex values are just derived from them. Okay, anyone has any question? So the last question, again, you don't know what this is, but this is just an angle, okay? So let this to be your theta. Now you know tangent theta is 1/2. According to the left graph, you just create any arbitrary triangle, What is if this tangent theta is over 1 over 3, so this side is 1, this side is 3. So hypotenuse is 1 squared plus 3 squared is 10. So hypotenuse is square root of 10. So this side is square root of 10. So what is sine theta? Sine theta is 1 over square root of 10. So it's square root of 10 over 10. That's it. Anyone has any question? Okay, make sure you read my gradings, my comments. And when you write your quiz, please make sure you also include your work. I see some of you just give me the answer, didn't write me the work. So I give half of the points. If you turn in the complete work, I give you 4 points for this time, just for this time. Next time, if I just see an answer, I don't see any work, you will just get half of the points. Okay. So stay here, I still need to take the attendance. Do not go, I still need to take the attendance.